Geometric sequences, the word geometric over here means multiply because in geometry, we multiply to get the dimensions from a line to a square to cube. We keep multiplying, in this case, by 2. And here are a couple of geometric sequences. And notice that if to get the next number, the first one I multiply by 2 each time. To get the next sequence, I multiply by 3 each time. So the r is equal to 2 and 3 respectively. Here is a sequence with r equal to 1 plus r. If I know the first term, I know the r, that I can form the formula for an by putting a1 here and r as the base. It's exponential formula. For example, here is a geometric sequence. How do I know? Divide consecutively the 6 by 2, 18 by 6, so on, so on. I get the same ratio 3. I know the first number 2, so I can form the specific formula for this sequence of an in nth terms is given by this formula. Here's another example with 2 terms in the middle. I know what this is and what a6 somewhere down the line that is. And so to solve, I don't know what r nor a1. So what I do is I put 2 and 6 into the general formulas, and that's supposed to give me -2 and 54 using this information. What do I do with these 2 equations? I divide them. Why divide? The a1 cancels out, and then I get equations in r, and I get I -3. Put -3 back into the r, and I can figure out what a1 is. Once I have r and a1, I can form the specific equations. How do I add them? Using this geometric algebra formula, notice this one, if I were to divide 1 minus r underneath, then I get the sum of this geometric series is equal to this. If I were to multiply this by a, then I get this general geometric sequence sum, and then all I have to do is multiply a to the formula. And so this is the sum formula for geometric series. And for example, find the sum of this series. Well, I know what the first number is, and after I divide, I can find out what I is. So now I need to know what n is for these formulas. How many terms are here? So I first make these specific formulas for these formulas. I want to check which number what n is, and that will give me these terms. So I set these terms to this formula and solve for n. And notice, if I compare the denominator, I get a simple exponential equation, in this case, n6. Once I know the sum, how many terms I can sum them using the formula, and that's it. Okay, bye-bye.